Hi, my name is Hang Liu. I'm an associate professor in the Department of Apparel, Merchandising, Design, and Textiles at Washington State University. I have been working on green chemistry and sustainable design related projects since 2008. This job as a faculty provides me a platform to work with a different group of people, and I can make a broad impact. I have 3 responsibilities as a faculty member. I teach, I conduct research, and I also do service and outreach. For teaching, I work with the students, I deliver knowledge, and I inspire students to learn. For the research part, I work with the industry to develop new technologies to solve industry problems, and I also work with the industry to commercialize the technologies. For outreach, I reach out to the society, the community that I live in, and I deliver my research finding, deliver knowledge, and at the same time, I increase the awareness of the matters related to the industry that I'm working for. To me, sustainability means that we utilize the resources that we have today to make products or goods to fulfill our today's needs, but at the same time, do not overuse, do not produce or generate environmental burdens for the future. I teach courses here at WSU in textile science and product development. And I do research on textile waste recycling, bio-based polymer product development, and also working on smart wearable engineering. For the textile waste recycling project, I'm focusing on cotton waste recycling. One of the factors that guided me to work on waste recycling is the increased awareness of the waste generation and the environmental issues related to textile waste. I remember seeing the pictures of piles and piles of clothing waste were buried in landfill. I started to think what I should do and what I could do to change it to increase the recycling rate. So I did some research and learned the technical hurdles for increase the recycling rate. And combining my textile engineering and the science background, I made the decision to work on recycling post-consumer cotton waste. There are some challenges out there. Some of the textile materials are not easy, are difficult to recycle, and some others are relatively easier. Cotton is heat resistant, which means it cannot be melted with heat. So when we have a t-shirt, cotton t-shirt, or a towel that is too old for us to reuse or repurpose to other products, we need to use some other recycling method, for example, chemical recycling, to break the product into molecular level and rebuild that into fibers for new products. The cotton is made of cellulose, which is a long-chain polysaccharide component, has many hydrogen bonds, and these hydrogen bonds form networks. So make the cellulose a very stable structure. So it's not easy to find a solvent that can dissolve cotton or cellulose and that does not hurt the environment. So this is one challenge when we use a chemical recycling method to recycle cotton-based or cellulose-based textile waste. So thinking about the recycling process, if we think in a holistic perspective, we do not want to use toxic chemicals to recycle, right? So in our lab, we have developed alkali and urea solvent mixture to dissolve cellulose, to dissolve post-consumer cotton waste. Yet these solvents are not toxic, and they're very commonly used, and they're not expensive. So the recycling process that we are using now is to use this solvent to dissolve cotton waste into a solution. Then we use a technology called wet spinning to extrude the solution into new fibers. These fibers are brand new, and they can be made into new clothing or new home textiles, and even for non-woven industry like webs. Besides textile waste, we also work on agricultural biomass. I learned that a lot of this biomass, agricultural biomass, in them cellulose is a major component. So we have working on adapting this technology to process and utilize agricultural biomass, especially the cellulose part, to make new products. And some of the cellulose, for example, in the textile waste products, the properties are even better than some cellulose obtained from other sources. For example, wood pulp is made of cellulose. So the cellulose in cotton fibers may have even better strength and better crystallinity than the cellulose obtained from wood pulp. So I would say the huge supply, the low cost, and the high quality. These are the reasons that we want to utilize these waste materials. And after I graduated with my PhD degree, I joined Washington State University. I was involved in a project to develop bio-based and biodegradable agriculture mulch to replace those non-biodegradable agriculture plastic mulches. That was the first time I was involved in green chemistry and sustainable design. And I was fascinated about the work and the field and the impact. As a material scientist, the green chemistry and the sustainable design can guide me when I design a product or when I develop a new material through selecting raw materials. What is more sustainable, what is biodegradable, what is renewable. The process, how do you reduce chemical use, energy use, and water use, and eliminate toxic chemicals. And also we need to think about the product or the material that you developed, if that is recyclable or compostable. So these are all areas that during the product development cycle that you need to consider. In school, we learn the basic knowledges, and also we develop our analytical, creative, and critical thinking skills. This will be very important for you later on to learn new knowledge and to become a problem solver. Take the advantage of the education opportunity that you have. Lay a solid foundation for yourself. So in the future, if you want to explore your dreams in different areas, then you have the solid foundation, the building blocks for you to continue working on.